How many times have you run an A/B test only to end up with an inconclusive results? Most tests fail before they even start because no one checked if there was enough traffic. Today I will show you how AI tells you in minutes whether your test will work before you run it, and what to do when you get the results, how to go beyond the aggregate number so you don't make the wrong call. All that with 2 live demos. I'm Nacho Bassino, and every week I share how to use AI in product management practices. And today we will talk about why running experiments in product should be straightforward. You have a hypothesis, you run an A/B test, you look at the results, and you decide. But if you have tried doing this with rigor, you know that's not how it goes usually. Before running the test, you need to know if it's even viable with the traffic you have in your product, how many users you will need, how many weeks it will take, and if you don't have enough traffic, what are your alternatives? This is called power analysis, and traditionally a data scientist or a specialized calculator handle it. Most people simply didn't do it and ran tests that never had a chance of reaching significance. And then when you have the results, you check the dashboard, see that this variant won, roll it out, and move on, without verifying if the split held true, without segmenting, without asking whether the aggregate number is telling you the whole story or hiding something. Ron Gohavi, who led experimentation at Microsoft and Airbnb, documented that only 10 to 20% of A/B tests show significant positive impact, just 1 in 8. So the post-test analysis needs to be deep. We need to go beyond that. And the pre-test design needs to be rigorous as well, or we are burning weeks on tests that will go nowhere. So what we need is a framework that covers the 2 critical moments of any experiment, the before and the after. And the good news is that with AI, you now have an experimentation expert available 24/7 that helps you with both. So the first step, before running the test, ask AI to evaluate whether it makes sense. This is power analysis, and now you can do it in 2 minutes with a prompt. You give it the parameters, your metric, the current baseline, the effect you expect to detect, your weekly traffic, and the AI will give you a viability table. How many users you need per variant, how many weeks it will take. And if it doesn't work out, what are your alternatives? Switch to a proxymetric higher up in the funnel, make a more aggressive change, consider a aggregate rollout. Think of it like checking if you have enough fuel before a road trip. Without that calculation, you might end up stranded halfway through a test that was never going to reach significance. The second step is when you have results. Don't stop at the aggregate number. Ask AI for a deeper analysis. The first thing it checks is SRM, sample ratio mismatch. If you design a 50-50 split and there is a large imbalance, something broke in the assignment and the results are unreliable. Most teams do not check this and can be a major cause of frustration or incorrect decisions. Then comes the most important part, which is the segmented analysis. AI analyzes each available variable separately, platform, user type, geography, whatever is useful for your product, looking for whether any segment contradicts the aggregate results. This is critical because sometimes the total says winner, but when we look at specific segment, it might be losing. It's called Simpson Paradox, and it's more common than you will think. That leads to the third step, the most nuanced one. The right decision is often not yes or no. It's yes for this segment in this context. If mobile wins and desktop loses, the answer isn't a general rollout. It's a partial rollout, and AI gives you a recommendation. Go, no go, partial rollout with justification by each segment. So let's see how this looks like in practice. Okay, we will create in Gemini this gem of the experiment analyst. And what is this about? The intention of the experiment analysis is to have something that can run continuously, giving us feedback, input when we are preparing a test, and also output when we execute the test and have a much more rigorous analysis of what's going on. So the role is an experimentation statistician, specialized in A/B testing. For digital products, you have 2 modes of operation. Mode 1 is pre-test, when I describe an experiment, and mode 2 is a post-test, when I share a CSV with experiment results. So more instructions on each of the modes. In mode 1 pre-test, when I give you test parameters like the metric, the baseline, expected effect, you respond with sample size table for different lifts, like 5%, 10%, 15%, with users per variant and weeks need according to the traffic I have. That also means that you will tell me about the viability. Can I run this test? If not, what can I do about it? And the risk that may invalidate the test. So very simple prompt, but very useful to use this once and again when I'm running different tests. The second mode, as we were saying, is when we are analyzing results. And here is a very important part, I would say, a few checks that we expect PMs to do, or PMs should do, and maybe they don't do regularly, because we can say, hey, this is the uplift and just roll it out or not, depending on the results. But there are nuances that we need to check. For example, the sample ratio mismatch, if we kind of distributed the people accordingly. If there is an aggregate result with statistical significance, this will be the most obvious result. But then a segmented analysis by each available variable in the dataset. And we'll see that in a second when we do it. And the Simpson Paradox detection if there is any segment that contradicts the aggregate result. And with that, go, no-go decisions or partial routes depending on the result. So as you can see, this is a very simple gem and very simple instructions, but you will see how powerful is this to, when I'm doing test day in, day out, I will be able to use this. I don't need to think again about the instructions I need to put to analyze the test I'm doing. So let's see this in practice. We will first view the mode 1 basically, and what I'm trying to do is I want to run an A/B test and help me evaluate if this is viable. I'm working in Product Growth OS, professional development for PMs. That's the product I'm building. I have a new onboarding with an app download prompt. This is coming from a past demo. If you haven't seen that video, refer back to that one. But basically, we detected that users who download the application have a higher retention rate, much higher retention rate than those who don't. So we want to compare that new prompt during the onboarding with the current onboarding that doesn't have that. The primary metric is 30-day retention, and we have a baseline of 45% retention, and the expected result is we estimate a net lift of between 10 and 15% based on observed correlations. So the mobile users retain at 33% versus desktop at 32%. Traffic is 120 signups per week, and we want to split this 50-50. So let's see the analysis. So as you can see here, it gives me the answer, sample size and duration table to detect these lifts with a standard statistical power of 80% and significant levels of 5%, which is kind of the very typical A/B testing standards. To detect a lift of 5%, so going for the 45% to 47%, you will need this many users per variant, which equals to 30,000 users, which for my traffic will be 256 weeks. So multiple years in order to get this result. If I want to detect 10%, I will need 73 weeks, so over a year. If I want to detect 15%, so that will be almost half a year. So if we are having a viability assessment, it will say, hey, this is not viable. It will take over a year to detect 10% lift. Even if you lift 15%, which is a very aggressive estimate, you will need 28 weeks, which is too long for a startup cycle, which is kind of the current condition of the company. So what we can do in terms of strategies, we can move up the funnel. So instead of using the 30-day retention, use the one habit, or if they download the app, for example. So these sort of things, we will have higher conversion rates and we will need less sample size. Same if we are doing an aggressive test. If you believe the app this is kind of the silver bullet, instead of prompting the user, let's make the onboard them mobile first. So we have a much larger expect effect. So we will need less or smaller sample size to detect it. Then there are other things like Bayesian testing. So I don't want to go into all the recommendations, but you can see that already give me kind of a very strong verdict and what I can do about it. And the last part is, hey, the risk of validation of how valid will be the result. So we can have selection bias. For example, the mobile user may be a fallacy. Maybe these guys who are more active do have the application because the most active users, the power users, are the ones who download the application. So if I incentivize other users to download the application, it will have no effect because I'm biased by only analyzing these power users. Also, we have the novelty effect. We may have the app download because it's new, but not actually engage more over 30 days. Technical attrition, the different things. Again, I don't want to go through all of them, but you can see they have very strong information, very strong analysis with a very simple gem and a small prompt of what I'm trying to do. Let's now go to analyze the results. I want to share the CSV that we have with the results. So as you can see here, very simple CSV, user ID, group, platform, user type. So you can see here that we have, well, of course, the group is the treatment and control, the platform is mobile or desktop, and the user type is new or returning user. And we have, if they converted, the 7-day retention rate, the 30-day retention rate. So this is a very simple result. We may have more variables, so more information about my user. It can be, for example, the geography or other parameters, plant type, whatever you want to use. But let's actually run the analysis. So I attach the CSV and I will just tell you, hey, here are the results of my A/B testing, analyze them in mode 2. And I have the same product. The test is a new onboarding with notifications and app download. And the duration is 4 weeks. And my primary metric is retention 30 days. Let's see what it tells me. What I'm fascinated about is that it will write code to actually extract information and do some calculations. So this is how cheap actually today coding is, that it will create code just for this session and it will delete it just to analyze my data. All right, and now I have the results. Based on the results here, the post-test evaluation. First of all, sample ratio mismatch. It passed because I have a control with almost above 1,000, but treatment is also almost 1,000. So there is no significant deviation from the 50-50 split. But here you can see that I already have a critical warning that the desktop users control had more users than the treatment, and for mobile, the opposite, control has less users than treatment. So even though the overall is okay, when I go to these small details, the imbalance is statistically significant. So the treatment group is heavily over-indexed on mobile users. With that, what is the result? The result is that it went from the almost 45 to almost 49, a lift of 95%. This is not statistically significant at 95% confidence rate. So on the surface, this looks like a directional win that just misses significance. This is misleading because this is artificial, because the treatment group contains more mobile users who naturally retain better. This is a very interesting analysis only by just kind of giving the CSV results, much more powerful than what some of the tools that you can use out of the box will give you. And if we go to the segment analysis, the true story emerges when we break it down by platform. So you can see that actually in desktop users, we have a negative lift. So it's significant, so it's powerful, and with a negative effect. And on mobile users, we have the opposite. We have a positive correlation, which is statistically significant. So while this 9% is not significant at a 95% confidence, we can go to each of these platforms and the test, if we isolate those users, the tests are significant and are telling opposite stories. If we turn this for desktop, the retention rate will drop. If we turn this for mobile, the retention rate will grow. So here is, hey, we detected a Simpson Paradox because the aggregate views suggest this 9% lift, but we have, for example, a 18% negative on desktop. So the recommendation, no go for a full rollout. The action plan should be a partial rollout, mobile only. This feature is a massive win for mobile. And if you think about it, it's kind of almost makes sense. If I'm on desktop, it's just me to download an app. If it's a bit of friction there, I will not do it because it means switching devices. Instead, if I'm in mobile, browsing the web on mobile, and you have a click to install, that may be a high conversion action. Okay, as you saw, in less than a minute, we discovered that what looked like a positive result was actually hiding two opposite stories per platform. If we have done a general rollout, we would have hurt retention by 7 points for the 43% of the users who uses desktop. This kind of segmented analysis is exactly what AI makes effortless. If you want to go deeper and practice this with real data in product direction community, that's exactly what we do every week. Live coaching with me, 10 modules of expert content, AI module, and a community of product managers helping each other out. The link is in the description. And if you're finding this useful, also hit subscribe for more content like this one. But let's recap what we have covered. Before running a test, ask AI to evaluate if it's viable with your traffic. A power analysis in 2 minutes, no more tests doomed to fail from the design stage. After the test, don't stop at the aggregate number. Ask for a segmented analysis, error verification, Simpson Paradox detection. The right decision is often not yes or no. It's yes for this segment in this context. I wrote an article with the full experiment analyst prompt, the before and after framework in detail, and the classic traps AI helps you avoid. Link in the description. And if you want my help applying this to your product, please go to check the product direction community. It's where we do that. Every week we meet live and you bring your real challenges and I give you direct feedback. Also, there is a 14-day guarantee, so it's not for you, no problems. And if you subscribe, in the next video, we are making a different kind of leap. We go from validating individual hypotheses to building a system that scales your judgment, your own AI coach. So stay tuned and see you in the next one.